Hi, this is your Professor Sudha Kolathuparambal, section 11.1, Hypothesis Test for Difference Between Two Means. Do the computer help high school students to learn math? So one way to address this question is to give a test to two samples of students. One from the population of students who used the computers in their math classes, and another from the population of students who did not. If the difference between the sample mean scores is large enough, we can conclude that there is a real difference between two populations. So let's look at this using an example. The scores on NAEP math test range from 0 to 500. A sample mean score for students using computer was 309 and sample standard deviation 29. And students not using the computer, the sample mean was 303 and standard deviation 32. So student using computer was 309, standard deviation 29. Not using was 303 and the standard deviation 32. Assume that there are 60 students in the computer sample and 40 students in the sample don't use the computer. We can see that the sample score differ by 6 points. So difference between these two is 6 points. So this is the sample mean. Now we are interested in the difference between the population mean. Is it possible that the difference between the population mean could be 0, or how strong is the evidence that the population mean score are different? So this is an example of a situation in which the data consists of two independent samples. So these are two independent samples, and the observation in one sample do not influence the observation in the another one. So here the issue is whether the mean score of both the population of students using the computer and those without computer, are they equal? So this will be the null hypothesis, and alternate hypothesis will be, there are three possibilities. It could be greater than or less than or not equal. Here mu1 and mu2 are the population means. Let's look at the notation used in this section. Mu1 and mu2 are the population means. x1 bar and x2 bar are the sample means. S1 and S2 are the sample standard deviation. N1 and N2 are the sample sizes. Here the test statistic is based on the difference between two sample means. The mean of the difference between two sample mean is difference between the two population means. This is the formula we use for the test statistic, and the degrees of freedom will be the smaller of n1 minus 1 and n2 minus 1. Assumption, we have a simple random sample of two population and samples are independent of one another, and sample size is greater than 30, or the population is approximately normal. The step-by-step procedure for the difference between two means using the p-value method is given below. First, state the null and alternate hypothesis. Then choose the significant level alpha. Then compute the test statistic, compute the p-value. Then interpret the p-value. We reject the null hypothesis if p-value is less than or equal to the significant level alpha, and then state a conclusion. Let's look at this example. This is the same example I explained on the first page of this section. So first check for the assumption. We have two independent random samples and both sample size greater than 30. state the null and alternate hypothesis. Now find the test statistic. I'm going to write down all the information from the problem in this table, so it will be easier to substitute the values here while calculating the test statistic. So this first column is with the computer. So with a computer, and other one is without a computer. So this is the students who do not use the computer. So sample mean is x1 bar, that is equal 309, x2 bar, that is equal 303, and sample standard deviation S1 equal 29, S2 equal 32, and sample size N1 equal 60 and N2 equal 40. In both the cases, population mean is unknown. So mu1 unknown, mu2 is also unknown. But under the assumption that the null hypothesis is true, so under the assumption so that means mu1 equal mu2 is true. That means mu1 minus mu2, that will be equal 0, right? If they are same, that will be the difference between them will be equal 0. So you can actually substitute that here. So this whole thing will be 0, and substitute the other values like a sample mean. From these two you can substitute. Okay, this is here. Okay, and S1 and sample size, you can substitute all these from the table, the same value, and calculate that. So I'm going to move to the next page. So I'm going to substitute those value. X1 bar is 309 minus 303 minus, that is 0, and sample mean is 29 square minus N1 is 60, then 32 square divided by 40. So enter all these into the calculator and round that into 4 decimal places. So 9533. So this is the test statistic. Now step 4 is find the p-value using the table student t distribution. So first we need to find the degrees of freedom. So find n1 minus 1, that is 59, 60 minus, because n1 is 60, right? And n2 minus 1, that is 40 minus 1, that is 39. So the degrees of freedom will be the smallest of these two. So degrees of freedom equal 39. This is a two-tailed test. So the p-value is the sum of the areas to the right of 0.953 and the left of negative 0.953. And these areas can be approximated by using the table A3, or you can use the calculator to find the values. If you are using the table, look at the row corresponding to 39 degrees of freedom. We see that the value of the test statistic 0.953 is between 0.681 and 1.304. And these are the values that correspond to the tail areas 0.025 and 0.10. Therefore, the area on each tail is between these two values. A smaller number should be on the left side. So, between 0.10 and 0.25. P-value is the sum of the areas in both tail. So, we double these numbers. So, if you multiply each one by 2, we'll get 0.02 and the p-value is between these two values 0.50. And step 5, since p-value is greater than 0.05, we will not reject at 0. There is no strong evidence against a null hypothesis. So, mean score may be same. If you are using the calculator to perform this hypothesis test, press stat, then test, then option 4, that is do SAM t-test. Press stat, test, option 4, highlight stats, enter sample mean, sample standard deviation, sample size for both with the computer and without the computer, and we are testing mu1 not equal mu2, and calculate. And from this we can find the p-value. So the p-value is 0.3434, which is a number between 0.20 and 0.50. So we do not reject the null hypothesis at alpha equal 0.05 level because p is less than 0.50. Now let's look at how to perform a hypothesis test for difference between two means using the critical value method. So first state the null and alternate hypothesis, then find the critical value at the significant level alpha, then compute the test statistic t. This is the same formula we used before. Then determine whether to reject the null hypothesis or not based on these conditions and state a conclusion. So let's look at an example. In this example, two methods of water treatment are being compared. So benzene concentration in units of milligrams per liter for each specimen are follows. So in treatment 1, there are 5 specimens and benzene concentration is given. Okay, and treatment 2, there are 7 specimens and these are the benzene concentration. And how strong is the evidence that the mean concentration is less for treatment 2 than for treatment 1? We will test that alpha equal 0.05 significance level. So first check for assumption. Because the samples are small, we must check for strong skewness or outliers. So we construct a dot plot for each sample. So here no outliers, no evidence of strong skewness. So we can proceed. So let's use the next page to write down the solution. So step 1 is state the null and alternate hypothesis. So this is a right tail test, alpha equal 0.05, and find the degrees of freedom. So here n1 equal 5 and here n2 equal 7. So n1 minus 1 is 4, n2 minus 1 is 6. So degrees of freedom is the smaller of these two numbers. So smaller is 4. So degrees of freedom is 4. So the critical value is the value with area 0.05 to its right. So in the student t distribution, look under degrees of freedom 4. This is a one tail right tail test and 0.05 significant level. So you can see that is 2.132. That means T alpha, critical value T alpha equal 2.132. Now find the test statistic. So step 4 is test statistic. So test statistic, we can use this formula, x1 bar minus x2 bar minus mu1 minus mu2 under the assumption that null hypothesis is true. Mu1 minus mu2 will be equal 0. So this will be 0. Substitute the other values and find the value for the test statistic. So we will get test statistic equal 1.590. This is a right tail test. And we reject the null hypothesis if t is greater than or equal t alpha. Here t is equal 1.590 and t alpha equal 2.132. That means t is actually less than t alpha. Okay? So we do not reject the null hypothesis at 0. Now state a conclusion. So we can conclude that there is no enough evidence to conclude that the mean benzene concentration with treatment 1 is greater than treatment 2. The concentration may be the same. So in this section you learn how to perform hypothesis test for the difference between two means using p-value method and the critical value method.